So now we're on the second part of this section, and that is solving radical inequalities. And the really important thing to first notice is that if you have an even index, so second root, fourth root, you have to make sure you restrict the domain here. So we don't want something like we have the square root of a -4 because that is our imaginary numbers. So we always have to restrict the domain if we have an even index. So what we're going to do is we're going to say the radicand is greater than or equal to 0 in order to get that restriction. So the steps are here. The first one does say, okay, restrict the domain. So that's what we're going to do first. We're going to take that radicand of 5x minus 10 and set it greater than or equal to 0. So go ahead and solve that. Remember, not in this case, but if we were to divide by a negative or multiply both sides by a negative, our inequality symbol would change always still. So hopefully you all were able to get x has to be greater than or equal to 2. Now, step 2, we're going to solve the inequality. So we're going to subtract 3, square both sides, and then get our solution. So go ahead and do that now. So hopefully you're all able to get x has to be less than or equal to 7. So we have x is greater than or equal to 2, and x is less than or equal to 7. So we're going to write that as a compound inequality. 2 is less than or equal to x, which is less than or equal to 7. Now we're going to check that. So we're going to pick a value less than 2, value that satisfies that, and then a value that's greater than 7. I'm using 0, 3, and 9. So when I put 0 in, I get 3 plus root -10 less than or equal to 8. That doesn't work because we end up with imaginary numbers, so that's a no. When I plugged in 3, I get 3 plus root 10. Now, I'm not going to bust out a calculator to figure out what root 10 is, but I know it's going to be bigger than 9, so I'll just say 3.1. And we get 6.1 approximately. So, is that less than or equal to 8? Yes. And then the same thing, I'm not going to figure out what root 35 is, but I know it's going to be a little less than 6 because the square root of 35 is 1 smaller than the square root of 36. So I'm just going to go with 5.9. So we get approximately 8.9. And is that less than or equal to 8? No. So our solution then is 2 is less than or equal to x, which is less than or equal to 7. So we're going to write that in set builder. So curly braces, x such that, and then we'll put the 2 less than or equal to x, which is less than or equal to 7. And as a graph, because it's less than or equal to, we'll do closed circles on both the 2 and the 7. And the value of x is any value that's between 2 and 7, including 2 and 7. So let's go ahead and try these next 4 out. What I did first is I just wrote down the radicand for each of those problems, and I said that the radicand has to be greater than or equal to 0 to find the restriction. So I want everyone to just do that part right now, pause the video, and let's check and see how we did. So for number 11, hopefully you all get x has to be greater than or equal to 1 when you restrict the domain. 12 should be x is greater than or equal to -1. 13 is a little trickier. You're dividing by a negative, so hopefully I put mine in red here. You reverse that sign. X has to be less than or equal to 9/5. And then for 14, we get x is greater than or equal to 7. So what I'd like you to do is pause the video again and solve the radical equation here and find your other variable restriction. All right, so for number 11, I got x is less than 10, and 12, I got x is greater than or equal to 7. So now we're going to put those together. I'm just going to make a quick little number line here, putting the 1 and the 10 here. So what you can do is you can pick some numbers that are in between those. I'll use 0, I'll use 2, and 15. And these are the numbers I'm just going to plug in to see where my solution will be. So if I put 0 in, I get 4 times 0, which is 0, minus 4, so I get a square root of -4. That doesn't work because we have imaginary numbers, so I can say that's a no. When I put 2 in, 2 times 4 is 8, and then minus 4 is 4, so square root of 4 is 2. So 2 minus 2 is 0. Is 0 less than 4? So this is a yes. And then when I go ahead and put the 15 in, I get 4 times 15, which is 60. 60 minus 4 is going to give me the square root of 56, which is going to be a little bit above 7. So I'll say like 7.2 there. And then minus 2 from that, I get 5.2. Is that less than 4? No. So you'll see that the solution is going to be greater than or equal to 1 and less than 10. So I'll put that in set builder. X such that 1 is less than or equal to x, which is less than 10. Make sure you change that symbol so it's just less than, not less than or equal to there. So go ahead and try 12 using those checkpoints and see what your solution is going to be. And I'll check in with you in just a moment. You may have picked other values, but I tested -2, 0, and 10. -2 didn't work, 0 didn't work, only 10 worked. So that means my solution has to be something that's greater than or equal to 7. So I'll just put that in set builder. X such that X has to be greater than or equal to 7. So go ahead and solve 13 and 14, and if you feel like you can do the check part, do that as well. Just be careful, you may have to divide by negatives, so please make sure you remember to reverse that sign. So I just wanted to do a quick screenshot in case you're nervous about doing the next part. Make sure you have the solved inequality correct. 13 is X is less than or equal to -11. Again, you have to reverse your sign there. And for 14, we get X is less than or equal to 331. Another one where we have to reverse our inequality symbol. So you can go ahead and test those out now if you feel confident. I'll show the answers in a moment. So for 13, I ended up checking. I got a yes, a no, and a no. So my solution is X such that X is less than or equal to -11. And then for 14, I have a no, I have a yes, and then a no again. So the solution set there would be X such that 7 is less than or equal to X, which is less than or equal to 331. So remember, we do have to restrict our domain because your radicand has to be greater than or equal to 0. So you have to make sure you do that part, then solve the inequality to find where the X values can be. Little note at the bottom, since your principal root is never negative, if you have less than or equal to a negative or less than a negative, that's a no solution. So you don't have to take your time to solve it. If you recognize that, only recognize it once the radical is isolated. But if you can recognize that, save yourself some time and don't go through all the steps. All right. Hope you understand this. We'll check your work out later. Have a good one. Bye-bye.